Dr. Sonia, if you could start introducing.
So once again, welcome Dr. Subrato Hathi sir. And yesterday he was there. He was with us. So Dr. Hathi is working as assistant professor in the Department of Dairy Microbiology, and he have published more than 130 research paper in reputed journal national and internationally. He has a citation of 3639, H index of 32, and I index of 1068, and total cumulative impact factor more than 300. So is a recipient of numerous prestigious award also, like university topper as a gold medalist in undergraduate program, best teacher award, ICR and AAU award, NAS Young Scientist Award, sponsored by NAS, Visiting Scientist Award 2018 by INSA New Delhi, and also the recipient of Dr. Mrs. Gauri Ganguly Memorial Award 2019 by Indian Science Congress Association, Kolkata. He has been also awarded as the Best Innovator Award by Microbiology Society of India, Maharashtra, and also visited the University of Copenhagen, Denmark, for presenting the research work under Indo-Danish Collaboration Workshop 2018. He is also elected as a fellow member of National Academy of Science, India, NAS, and associate fellow of NAS, WST, and NRC. He also received BRICS Young Scientist 2021 by DST New Delhi. Also awarded with the International IFST Award, ILSI Award, like that. So please, once again, welcome Dr. Subrato Hathi sir, and his topic of presentation is production and characterization of milk peptides from non-bovine species, science to application. So Dr. Hathi, please.
Good afternoon all. Thank you for nice introductions. So again, I am very much thankful to the organizers, especially Dr. Sonia Madam and another organizer from Jammu and Kashmir. So today I will discuss, or I will cover the topic of very interesting topic, that is which I am working last 13-14 years here at Anand. It is the production and characterization of milk peptides from the non-bovine species. So yesterday we are talking about the bioactive compounds present in the fermented foods or fermented milks. So one of the bioactive compound is the bioactive peptides. So today we'll discuss in detail about the role and functions and how we can purify those peptides from the milk, especially non-bovine milks. Even I'm also working in cow milk or buffalo milk also, but for this presentation I will cover only the non-bovine species. So in brief introduction about the topic is that the exploration of non-bovine milk has gained prominence due to its potential to cater to diverse dietary preference and also provide the unique bioactive compound. So the non-bovine milk, basically cow, buffalo, goat, sheep, mainly the goat, sheep and camel, they are very popular in our country, and all these non-bovine milks have a very particular bioactive compounds, and their composition is completely different from the cattle milk like cow and buffalo milk. So we'll discuss that what kind of changes are there in the composition of the milk. So the bovine milk or non-bovine milk, the ratio is very low in our country, but still that non-bovine milks are taking interest in coming future, because if you look to our state in Gujarat, you can see here that the Kutch area, it is very popular with camels. Okay, around 500 to 600 camels are there in just the Kutch region, and Amul has installed a plant called Sarhad Dairy, and they are collecting around 6,000 liters milk per day, from 5 to 6,000 liters camel milk per day from Kutch area, and they are processing it. They are making different kinds of milk products like ice cream or sterilized milk or UST camel milk, or they are very popular is the camel milk chocolate. Okay, so the camel milk is now getting interest because of their particular health benefits like anti-diabetes. Similar for the other milk like goat and sheep, they have a different therapeutic values. Okay, so this non-bovine milk cannot be compared with the yield and other things with the cow and buffalo, but their therapeutic values is quite high than the cow and buffalo milk. So here, this is the uh, importance of the non-bovine milk for great demand in the future for a particular therapeutic purposes. So diversity of non-bovine milk, basically their composition difference with the cow and buffalo. Proteins, the non-bovine milk typically contains the proteins with distinct structures and amino acid compositions. If I take the example of goat milk, it has different types of casein proteins compared to the cow's milk, influencing its coagulation properties. If we take the example of fat, so different variation in the types and amounts of fat present in non-bovine milk contribute to difference in the flavor, texture, and nutritional characteristics. Sheep and goat milk have a higher levels of certain short-chain fatty acids, as we discussed last class or last lecture about the short-chain fatty acids. It has a very good role in your gut. Gut means in your GI tract, because the short-chain fatty acids can inhibit the growth of pathogens, and mostly the short-chain fatty acids are butyrate, propionate, and acetate, and they have a high pK values also than the lactate. So these short-chain fatty acids are very much important to maintain your gut health by controlling the uh, growth of the bad bacteria, mainly the unhealthy bacteria which are present in your gut. So this short-chain fatty acid ACFA has a very important role. Then vitamins, non-bovine milk sources offer unique profiles of vitamins. If I measure the camel milk, it has a good amount of vitamin C compared to the cow and buffalo milk. Lactose, non-bovine milks often contain lower level of lactose than the cow's milk. So those who are having the problem of lactose intolerance, they may take this one. Now coming to the peptides, basically we'll talk about the peptides throughout my lectures. So peptides, the word came from the Greek word peptos. Peptos means digested. So when you will hydrolyze or digest the proteins, it will generate or release the smaller fragments of the proteins, which we call peptides. So there are different, the hormones, basically they are peptide also. Vasopressin, oxytocin, defensin, and angiotensins. They have a different roles. The vasopressin, they regulate the water in fluid surrounding cells. Oxytocin, they create feeling of love and bonding. Defensins, it helps with wound healing. And angiotensin, it regulates the blood pressure. So now, what is the difference between peptide and bioactive peptides? Because whenever you will break the proteins, it will definitely generate the smaller fragments of the proteins. It is called peptide. But when we should call it as a bioactive peptides, we can call it as a bioactive peptides if it has some kind of health beneficial properties, or it can give some kind of uh, you can say that some kind of uh, properties which directly related to some metabolic diseases, okay, that can be prevented by these bioactive peptides. So bioactive peptides can be released through one of the following ways. First is the hydrolysis by the digestive enzymes, because when the protein will go to the stomach, pH, these proteolytic enzymes can break these proteolytic enzymes can break the proteins in the stomach, and then these fragments of the proteins will generate it. So it is because of the digestive enzymes. Then enzymatic cleavage by the proteases derived from the microorganisms or plants. So basically we are working here with lactic acid bacteria, because lactic acid bacteria are highly proteolytic, and they produce different kinds of proteases, and that proteases or peptidases or aminopeptidases, that will break down the proteins into very smaller fragments, and then peptides will be generated or bioactive peptides will be released. Even some of the enzymes which can be extracted from the plants, okay, that can also be used for the preparation of the peptides. When we'll make the foods through following different food processing parameters, maybe acid treatment, alkaline treatment, or heating, so even we can add some enzymes or other processing parameters, maybe that can change the protein structure, or that can break the protein structures, and we get some amount of bioactive peptides from food processing. So the activity is of a bioactive peptide is totally dependent on the amino acid composition and their sequence. Sequence means the order of the amino acids, how they are present in a proteins or the long chain of the polymers of the amino acid residues. The size of active sequences may vary from 2 to 20 amino acid residues, and many peptides are known to reveal the multifunctional properties. So basically, bioactive peptides, they are chain, means number of amino acid residues in a chain, is from 2 to 20 amino acid residues. So you have to remember that the peptides will be not more than, bioactive peptides will be not more than 20 amino acid residues, but the lower one, 2 or 4 or 6 amino acid residues, they're very smaller one, which can be transported easily into the blood circulation systems, and you will get the benefits out of it. So again, the number of amino acid residues in a chain of a smaller fragments of the peptide is very important, and the presence of the amino acid, means what kind of amino acids are there, and their order of sequence is also important. Non-bovine milk naturally contains an array of bioactivity due to lysozyme, lactoferrin, growth factors, or hormones, which are secreted in their active form by the mammary gland. So these are the different uh, non-bovine species. They produce the milk, and that milk has a different kinds of health benefits when we digest or when we ferment that milk, and we get different kinds of health benefits like antimicrobial, anti-diabetic, antioxidant, and anti-hypertensive. So we'll discuss one by one of all those non-bovine species. The first one is the goat milk. So goat milk contains around 30 to 35 gram per liter of total protein, and of that protein, similar for the cow or buffalo, 80% casein and 20% whey proteins. They are the major protein in the milk. It is also considered to have a fewer allergens and may replace the human milk better than cow milk. So this is the benefit of that goat milk. And the more open structure with a thinner protein strands of the acid-induced coagulate from goat milk is a potential advantage, and this would allow greater diffusion of pepsin, and hence digestion of the casein proteins are more easy in goat milk. So when you will digest the caseins, because their structure is more porous, more opaque, so the enzyme can easily digest the caseins, and you will get a good amount of coagulated proteins. And if you see the composition of the caseins of the goat milk, these are the very prominent amino acids are there in milligram per gram. Nitrogen, histidine, isoleucine, leucine is quite high, 610. Then lysine, phenylalanine. So this is the series of amino acids present in the goat milk in good amount. Then if we see the population of the goat in India, if we start from 1951, as per the NDDB data, this is the trend, the number of population of goat is increasing up to 2019. It is started with 47, now it is in 2019 it was 148 millions. So it is a good sign that goat milk or number of goats are increasing from 1951 onwards. And these are the different breeds which are very popular in different states of the country. Okay, in Gujarat, we are working in Shruti breed. It is very popular in Gujarat, so we are working in Shruti breed, means the milk from the Shruti breeds, and it has a very good therapeutic values as we have evaluated. Then camel milk is the white gold of the desert. The protein content ranges from 12.15 to 4.9%. Camel milk contains mainly caseins, around 80% of the protein content, that includes alpha-1, alpha-2, beta, and kappa casein, with a mean concentration of these things. And camel milk is rich in alpha-lactalbumin, followed by serum albumin, 35% around. But the main advantage of the camel milk is that almost negligible amount of beta-lactoglobulin present in the camel milk. Okay, because beta-lactoglobulin basically cause the allergenicity to the persons who have some allergenic problem when they consume milk. So camel milk is quite helpful for them, those who are having these allergen problems, because camel milk contains very lesser amount, almost negligible amount beta-lactoglobulin. If we see the population of the camel in India, it is decreasing. If I take the example of Gujarat, because last year we visited the Kutch area, because I'm working in camel milk. So the federation, means Gujarat Cooperative Market Milk Federation, they invited me to deliver and lecture in Kutch, because they have installed a camel milk plant there, Sarar Dairy. They're also producing other milk products, but their main target was to produce the camel milk products. So I went there, and the camel breeders, or you can say the camel milk farmers, they basically are not interested to keep the camels, because to keep a camel is very challenging job. You cannot keep them in a very, the cattle farm or like that. You have to allow the camels to walk at least 20 to 30 kilometers a day in a very the deserted road, or the road or is not so much good that in every season they will walk better. But it is their practice, they have to walk around 30 kilometers, 20 to 30 kilometers. And the breeders or the camel milk farmers, they also have to walk with the camels, because the camel grazing is very important. And secondly, the feeding pattern of the camel is completely different from the other animals. Okay, because they basically take those plants which have some nutritional or some ayurvedic plants, you can say, or the herbal plants. So they consume these kind of plants, and because of the medicinal values of the plants, it goes to the milk. So we get that therapeutic benefits of the camel milk is coming from their feeding systems. And secondly, when we talk about the camel milk farmers, they are not interested because of their feeding systems and their walking systems. And most importantly, they are not getting the profit. Means the camel milk, nobody is uh, consuming the camel milk from them, so they are not getting money also. Now the federation means the Amul makes a society over there, and they are giving good amount of money around in 2024. It is per liter they are giving 51 rupees to the camel milk farmers. Now they are taking interest, they are breeding the camels, they are keeping the camels with them, because they are getting good amount of money. But if we take the example of the Rajasthan, where there is more than 4,000 camels are there, but their camel breeders are not getting that kind of money as the Gujarat farmers camel breeders are getting. So when the farmers will get the money, then only they will take the interest to keep the camel with them. So main important part is there, that first we have to see the population pattern. So from 1951 you see that up to 1982 it is increasing, but after that it is decreasing. But now the government, as well as state government, as well as the central and the Amul, they are taking interest, because the camel milk has some kind of therapeutic values and medicinal values, which we have to explore, so that the couples, they can consume camel milk, and we have to make it available to them. Okay, then only the camel breeders will get the money, they will keep the camels, and their population will increase. uh, I don't know in 2025 or 2024, maybe it's an increasing trend, but we did not have the data. Then sheep milk, there are approximately 40 primarily dairy sheep breeds out of 180 breeds that are milked. Sheep milk protein content is around 45 to 72 gram per kg of milk, 41 to 66 gram kg of which is are caseins, and 8 to 16 gram per kg are whey proteins. Caseins exhibit the heterogeneity due to the genetic variants, and the most abundant sheep milk casein is the beta casein. It is around 42% of the total casein on average, ranging from 31 to 58%. And if you see the population trend of the sheep in India, it is quite promising, because they started with 39.1 millions. Now it is 74.3 millions in 2019 data. Maybe it will be higher in 2024 and 2025. So these kind of populations are increasing, because the camel has, sheep has a two, three purposes to keep it with the farmers. One is the milk, then meat, and you can see there we can make the winter clothings from the sheep's fur. Okay, so they have a different purposes to keep the animals with them, and they have a good amount of useful things. Then donkey milk. Nowadays, donkey milks are again another non-bovine milk which people are trying to have it for different purposes. It is low in fat, poor in protein, especially in casein and calcium is lower, but larger proportion of lysozyme and lactoferrin is there in the donkey milk than human milk, and it is a rich source of lactose. Donkey milk has more whey proteins and fewer caseins, so it is completely opposite to the cow and buffalo and other milks. See, the whey protein is quite high in the donkey milk than the caseins, because whey proteins is increasing means you will have a more amount of the basically those proteins which will give you the muscle buildings proper, and whey proteins also have lactoferrin. So this kind of proteins, very good amount of proteins are present in the whey proteins, and their amount is quite high in the donkey milk. Donkey's milk has a quantity of alpha-lactoglobulin resembling that identified in human milk, and has a high level of beta-lactoglobulin, which is not found in the human milk. And if you see the populations, it is decreasing. If we start with 1951, it is only 1.3 million numbers. Now it is very less, 0.1. So the donkey population is decreasing. But again, the government has to take the initiative to make the numbers of animals more. It is only possible when the usefulness of the donkey or donkey milk is increasing, then only the population will be higher, then only the farmers will keep the animals with them. So this is the another important non-bovine species. Then another is the yak milk. Yak is another non-bovine animal. It is also called natural concentrated milk. Yak milk, with its important protein and lipid proportion, appears as a thick liquid. It is highly valued for making butter and traditional cheese. Yak is raised in the high altitude areas characterized by the extremely cold environment and low atmospheric pressure. So you can understand that at which environment they can survive, and they can produce the milk to the humans who can take their milk and get the nutritions. The milk contains around 16.9 to 17.7% solids, 4.9 to 5.3% protein, 5.5 to 7.2% fat, and 4.5 to 5% lactose, and 0.8 to 0.9% mineral. So you can see the total solids content. It is quite high by compared to the other milks. 16.9 to 17.7 is very difficult to get in any cow, buffalo, or any other milks. But if we see the population of yak in India, it is quite constant. It is not increasing or decreasing. But there is an institute, Yak Institute in Northeast area. They are basically maintaining all the data, and they are taking interest to explore the therapeutic benefits of the yak milk, so that the farmers can keep the yak with them. Now we can compare the composition of different milks from different mammals. So cow, buffalo, goat, sheep, camel, yak, donkey. And you can see that sheep milk has a more total solids, then protein content, fat content, ash content, and energy also. So sheep milk is a rich milk because they have a good amount of fat, good amount of proteins, okay, and as well as the energy also is quite high in sheep milk. Then we can see the different protein compositions, okay, protein profiling. So in total casein, the sheep casein is quite high, 41 to 66 gram per kg. In sheep milk, you can see the total whey protein is also high, and lactoferrin is quite high in the sheep. So these are the different proteins or different kinds of fractions of the proteins which are present in 5 different non-bovine milk: camel, goat, sheep, yak, and donkey. Sheep milk is quite high with the casein and whey proteins as well as the lactoferrin content. If you see the amino acid composition of all the non-bovine species, goat, sheep, camel, yak, and donkey, and you can see that histidine level is quite high in the goat. Then leucine is high in yak and donkey. Then proline content is high in yak. Tryptophan is high in goat, and 309 is also high in the sheep, and valine is high in goat milk. So different milk has a different amino acid content, and there's amino acid. Mostly all the non-bovine species, mostly they contain all kinds of essential amino acids in the milk, which is good sign or positive sign for the nutrition purposes. Now I will talk about the different biofunctional properties. Okay, so first is the anti-diabetic activity. Anti-diabetic activity, we know it is comes from the diabetic range. So diabetes mellitus is a group of disease characterized by the excessive blood glucose level, which is a common problem worldwide, particularly in India. And there are two types of diabetes. One is the type 1 and type 2. We know the type 1 and type 2. So mostly the type 2 diabetes is a critical condition caused by the lack of insulin or insulin resistance. So the type 2 diabetes is the one of the most serious metabolite syndromes affecting many people every year around the world. And in 2017, around 451 million people worldwide affected, and their age group is in between 18 to 99. They suffered from type 2 diabetes. And by the year 2045, it is predicted that this number will rise to 693 millions. So it is quite alarming that type 2 diabetes number of patients are increasing day by day in most of the countries, even in India also. So how these peptides will help you to control the diabetes? If we eat the carbohydrate like starch, so there are enzymes called alpha amylase or alpha glucosidase. They basically degrade or hydrolyze the starch, oligosaccharides or polysaccharides, and then they make it in a monosaccharides, means in glucose, by following a different pathways. And when the glucose level will be high, it will get absorbed to the blood circulation systems. And if it is not utilized, that glucose, so the blood glucose level in the blood will increase. And if it is not utilized, then we call it as a diabetes patient or diabetic conditions. So carbohydrate digestion begins with the action of the alpha amylase or alpha glucosidase, followed by insulin secretion by the GLP-1, glucagon-like peptide 1, in a glucose concentration dependent manner, and thereby reducing the postprandial blood sugar fluctuation. So basically, these enzymes, alpha amylase, alpha, mainly the carbohydrate digestion happens in the mouth, in the oral phase. When you will eat any carbohydrates, the digestion starts from your oral phase, because these enzymes are present in your saliva, and it starts to hydrolyze the starch or other oligosaccharides or other complex carbohydrates, and slowly they release the glucose in a step-by-step process. And as the glucose will absorbed immediately, and then it will go to the blood, and their level will increase. And if it is not utilized, then at a certain level, you will call it as a diabetes patient or diabetic conditions. The dietary carbohydrate starch is hydrolyzed by the pancreatic alpha amylase and absorbed in the intestine with the help of the intestinal alpha glucosidase. Inhibiting the said enzymes can be strategically used for managing type 2 diabetes, where the rapid utilization of dietary carbohydrates could be retarded by the alpha glucosidase inhibitors, thereby suppressing the postprandial hyperglycemia. So basically, these enzymes, alpha amylase or alpha glucosidase, which basically helps to hydrolyze those carbohydrates immediately and release the glucose. So the peptides which have the capacity to inhibit the activity of these enzymes, alpha glucosidase or alpha amylase, okay, so that the blood glucose release will get stalled, means slowly it will release, not in a very rapid manner. So the utilization may takes place slowly, so that the level of glucose will not increase. So the peptides like IPVDM and ALPEA, that kind of pentapeptides or hexapeptides, that peptides can inhibit these enzymes, alpha amylase and alpha glucosidase, and they can control the blood glucose level as the glucose will release slowly. One of my students worked in camel milk on anti-diabetic effect. So he estimated the alpha amylase inhibition activity and alpha glucosidase inhibition activity. So first we have fermented the camel milk with Lactobacillus plantarum. These cultures was used and on a certain conditions, means the growth conditions was optimized, and then we have checked the alpha amylase activity at different hours, 0 hour, 6 hour, 12 hour, 24, 48 hours. So you can see that after 48 hours, it is inhibiting a quite promising results are getting from these alpha amylase inhibitions, even in the alpha glucosidase also. So then we have passed these water-soluble peptides through different cutoff membranes, 3 kDa permeate and 3 kDa retentate, and here 10 kDa permeate and 10 kDa retentate. And we have again estimated the alpha amylase inhibitions and alpha glucosidase inhibitions. And we have find out that the permeate means low, less than 3 kDa, okay? And 10 kDa permeate means less than 10 kDa permeate, means less than 10 kDa molecular weight peptides. They are inhibiting quite high, around 80 to 80%. But the retentate, they are also inhibiting, but the peptides with the smaller fragments, they are inhibiting more. Similar for the alpha glucosidase inhibition also. You can see here the less than 3 kDa peptides are inhibiting quite high compared to the more than 3 kDa peptides. So we have tried to check, and then we have sequenced those peptides. Okay, so these are the different fragments of the peptide generated from the alpha caseins, alpha S1 caseins and alpha S2 caseins and beta casein from the camel milk. And these peptide sequences were matched with the Biopep database. There is a one website where you can match your own sequence with the other already reported sequence to match, because to know their biofunctionalities. So these sequence, they have a anti-diabetic activity. So you can confirm it by matching with these already reported sequences present in the Biopep database. Another study by Zhang in 2015, they isolated and identified the novel DPP4 inhibitory peptides. These are the DPP4 inhibitory peptides. It is also from the goat milk caseins. They have hydrolyzed the goat milk casein with trypsin and chymotrypsins. And then they have checked and they find it out that these DPP4 means the anti-diabetic peptides are there. Another work by Gong et al. In 2020, they also find out some anti-diabetic peptides from the goat milk, okay, from alpha S1, alpha K2, and beta casein. These are the different peptide sequences. They find it out from the goat milk. If we talk, as we are talking about the anti-diabetic effect of the camel milk, okay, you see the insulin content in 1 liter of camel milk, around 40 units. Insulin level, you can see that camel milk has around 58.67 unit per liter of the camel milk in average, compared to the cow and buffalo. So you can see here it is a 3 times, this camel milk has a 3 times higher insulin content than the cow and buffalo. So the camel milk is good for diabetes because their insulin level is quite high, okay. And also we have find it out that some of the peptides which is having the anti-diabetic effect because they are the insulin-like proteins, okay. So because of these insulin and insulin-like proteins, these camel milk showing good amount of anti-diabetic effects. We have also worked on camel milk for anti-hypertensive as well as the anti-diabetic effect in vitro. So we have checked the fermentation pattern of the camel milk. Then we have checked the inhibitions of different enzymes like alpha amylase, alpha glucosidase, then lipase, and AC inhibition. AC inhibition basically anti-hypertensive. So we have checked these fermented camel milks at different incubation times, and these are the results we have find out against these enzymes. And we have also do the sequence of those peptides after doing the SDS and 2D page, and we found very good and promising sequences of the peptides. Again, we have worked on the anti-diabetic and anti-inflammatory of the camel milk, okay, for the same kind of camel milk, but the culture is different. Okay, here we have used the lactic caseae Bacillus paracasei, and here we have used the Lactobacillus rhamnosus, and before it was Lactobacillus fermentum or plantarum. So we have changed the cultures, and we have find out that these camel milk peptides through fermentation is showing a very promising result against these anti-diabetic or anti-inflammatory and even ACE inhibitions. So here we have checked the anti-inflammatory. Anti-inflammatory we have done on raw macrophage cell line. So first we have checked the percentage of cell viability to decide the dose of the camel milk peptides. Then we have checked the nitric oxide productions. You can compare the control, the LPS increasing the highest nitric oxide production, but when we are giving these camel milk peptides, you can see the nitric oxide production is at par with the control. And when we are giving LPS plus camel milk peptides, compared to the LPS alone, you can see significantly it is reducing the nitric oxide production. Similar for the IL-6, IL-1 beta, and TNF alpha. So for all these three inflammation marker, you can see that with the control alone LPS, it is quite promising because it is significantly reduced the IL-6 and IL-1 beta and even TNF alpha, tumor necrosis factor alpha. So we did it in the raw macrophage cell line by inducing the LPS. LPS means lipopolysaccharides to increase these inflammations, and these camel milk peptides have the capacity to reduce the inflammations. And all this work has been published in very reputed journals. These are the sequences we have find it out from the camel milk from our own lactobacillus cultures, indigenous lactobacillus cultures available in our department. So these are the sequences which are being extracted, identified, and characterized from the fermented camel milk with different kinds of lactobacillus culture, M11, KGL3, and KGL4. We have also worked in the buffalo milk and camel milk. Okay, so we have compared the, because in nowadays you can see that buffalo milk is a A2 milk. Okay, so now people are increasing the, that means there is an increased demand of the buffalo milk in Gujarat. The Amul is selling the buffalo milk as a A2 milk, and they are charging more, and people are very much happy with this buffalo milk as a A2 milk. So we have compared the fermented buffalo and camel milk on anti-inflammatory, ACE inhibitory, and anti-diabetic properties, and also we have checked this what kind of peptide sequences are there, because we are getting promising results in all these inhibitions of the enzymes and the sequences, also in case of the inflammations. So these are our different works of the camel milk and goat milk on anti-hypertensive or anti-diabetics. So next is the ACE inhibition. ACE means anti-hypertensive effect. ACE means angiotensin converting enzymes. So that enzymes regulates the blood pressure via RAS system, renin-angiotensin systems, because the ACE converted S1 to S2. When it is S2, ACE2, in corona time, ACE2 is the receptor for the coronavirus to get attached. Okay, so ACE2 is very harmful to our system, human systems. So we have to block the conversion of ACE1 to ACE2. So if AC2 is more, then your blood pressure will be high. Okay, increase the sodium levels and blood pressures. So different pharmaceutical drugs are there. Basically, that drugs target the ACE enzyme so that your blood pressure will not get high. And food-derived ACE inhibitor, the bioactive peptides, they are believed to be safer than pharmaceutical drugs, and to lack of some drug-associated adverse side effects such as cough and angioedema. So basically, drugs have some side effects. So if we can give some food-derived peptides to control these or to manage the hypertension, it is a good one. But again, we cannot directly compare with the medicines with the food. So angiotensin 2 mediates its biological function through binding with the 2G protein coupled with the receptor AT1 and angiotype 2 receptor. So AT1 receptor is associated with the vasoconstrictions or constriction and inflammation, growth, and fibrosis, while AC2 receptor is associated with apoptosis and vasodilation. So AT1 is very much detrimental when they are getting activated and increase the blood pressure. Not only they increase the blood pressure, they will enhance the inflammations, fibrosis. So these peptides, they can block the conversion of S1 to S2, AC2, and they will help you to manage the blood pressures. So we also worked in anti-hypertensive activity of the camel milk, mainly the fermented camel milk. So we have used here in a combination of two cultures, Lactobacillus plantarum, as well as we have added the yeast also, Saccharomyces cerevisiae, in a combination with ferment the camel milk, and we find out 6 different types of peptide sequences, which peptide sequences are having the anti-hypertensive activity. And this sequence TD, VMP, Q, WW, this sequence having a more anti-hypertensive effect, and it is present in both the camel milk fermented with 2 different cultures, lactic bacilli paracasi and lactic plantivacillus plantarum. So these peptide sequences or these peptides have a very good impact on anti-hypertensive. We have also worked anti-hypertensive in 2014. First, we started work on peptides on camel milk, and we find out different sequences from different cultures, Lactobacillus delbrueckii, subspecies bulgaricus, then Lactobacillus fermentum, Lactobacillus plantarum, and these cultures produce different kinds of sequences. And these sequences now we have deposited, or you can say submitted in the NCBI as our Indian origin peptide sequences from the Kutchi camel milk breed. So when we started the work in 2014-15, we could not match the sequence because from our country, from India, nobody has deposited the peptide sequences of camel milk origin so that we can directly match with the sequence from our own breed. But nowadays, people can use our sequences to match with the any kind of non-bovine milk because we have characterized and we have deposited in the NCBI or Bioactive databases. We have also worked on goat milk for anti-hypertensive effect, and these are the different peptide sequences isolated from the 3 kDa, 10 kDa, and 3 kDa, 10 kDa different permeates fermented with different cultures. Okay, and these sequences have a anti-hypertensive effects. People's also worked on anti-hypertensive peptides from different non-bovine milks like goat milk, camel milk, sheep, yak, and donkey. And these are the sequences already being reported and submitted in the Bioactive databases. They have given the source from where the sequences are being extracted. Basically, you can see the casein. Most of the peptides are released from the caseins, beta casein and alpha S2 caseins. Very rarely they extract the peptide sequences from whey proteins because whey proteins are quite strong proteins. They are basically denatured and their amount is also less. So it is very difficult to extract the peptides from the whey proteins, but caseins are more porous, more opaque for reactions. We can do easily the hydrolysis of the caseins and we can extract these peptides. Then another one is the antimicrobial activity of different non-bovine milks. We know that how the antimicrobial works. They basically target the foodborne pathogens by following different mechanisms. Okay, so Bacillus species derived protease hydrolyze the sheep caseins, and that hydrolysates has the effect against different pathogens or spoilage causing organisms like Corynebacterium fumi, Bacillus cereus, Aspergillus fumigators, and Penicillium expansum. So basically the proteolytic enzymes they have extracted from the bacillus, and then they hydrolyzed the sheep milk with these proteolytic enzymes, and these hydrolyzed has been used. Basically, these are the different peptide sequences generated from these sheep milk casein hydrolysates, and that hydrolysates or that kind of peptides have the impact against these kind of spoilage causing or pathogenic fungus or bacteria. When the yak milk was hydrolyzed by pepsin, the hydrolysates produced are found to possess antimicrobial activity. So they have also generated the hydrolysates or fragments of the proteins from the yak milk, and that yak milk hydrolysate has the capacity to work against these E. coli, Listeria, Inoqua, Salmonella paratyphi, Enterobacter cholerae, and some of the fungi also. So they can inhibit their growth. These two peptides generated from the yak milk hydrolysates with pepsins. Then there are around 83 antimicrobial peptides are already reported, and they are basically extracted from the alpha S1 casein, alpha S2 casein, beta casein, and kappa casein. And you can see here that more antimicrobial peptides are being extracted from the beta caseins, and these antimicrobial peptides have or they are effective against gram-positive and gram-negative bacteria, as well as some of the fungi also. These are the antimicrobial peptides derived from the different non-bovine milks like goat, camel, sheep. Basically, these peptides we have worked here in our lab. One of my MTech students, he extracted these peptides from the sheep milk, and these peptides has an antimicrobial effect. Similar for the camel milk and goat milk. Then next is the antioxidant activity. The antioxidant activity of the lactobacillus cultures depends on the ability of a molecule to capture the free radicals. We know that how these peptides or some of the antioxidant molecules, how they work to absorb or scavenge those free radicals, okay, like singlet oxygens or peroxides or superoxides, and they scavenge those free radicals and they reduce the cellular damage, and it is called antioxidant activities. Okay, so this is the mechanism through which these molecules helps. Generally, two methods are employed to determine the antioxidant activity. The first one based on the HAT, hydrogen atom transfer, in which the capability of an antioxidant compound to scavenge the ROS, reactive oxygen species, in the substrate by donating the hydrogen atom is measured in a competitive manner. And the second methods are based on the electron transfer, in which an antioxidant is estimated by comparing it with a certain oxidations. So basically, these are the peptides we have isolated or purified from the fermented camel milk with the help of this cultures lactic bacilli casei. And these five different peptides, they have showed good amount of antioxidant activity through three different tests we have done: ABTS, then that is called free radical scavenging assay, FRSA, and another one is superoxide radical scavenging assay. So we have done three different antioxidant activities, and we got very good results. And you can see that how this incubation hours is increasing, the activity is also increasing, means the percentage of scavenging is increasing with these peptides or through the fermentation system. So these are the different peptides we have extracted from the camel milk, and these, because of these peptides, these activities increasing with the time. We have also checked the antioxidant activity from the goat milk. Again, we have used our own culture, Lactobacillus fermentum, and the goat milk is from Shruti breed in Gujarat, which is popular in Gujarat. So we have fermented that goat milk, and then we have analyzed the antioxidant activity through these three methods: ABTS assay, then hydroxyl free radical scavenging assay, and superoxide free radical scavenging assays. And you can see that for these three, if we ferment for 40 hours, that all these three scavenging activity is increasing. Similar for the incubation time also, and incubation rate also. And then we have checked these protein profile through SDS page and 2D, and we got these sequences from this fermented goat milk with M4 cultures by passing through different cut-off membranes. And these peptides have an antioxidant activity when we matched with the PIR or Bioactive database. These are our publications from these different goat milk peptides extracted and isolated. We have also worked on antioxidant activity of the sheep milk. Okay, so sheep milk, basically Panchali breed is very popular in Gujarat. So we fermented this Panchali sheep milk, and then we have checked their antioxidative activities, and also we have checked the anti-inflammations. Okay, so these peptides have shown very promising results. These are the peptides extracted from the fermented sheep milk with the KGL4 basically Lactobacillus rhamnosus, and these peptides have a very good peptide ranking score, and they are non-toxic. Okay, and anti-inflammation also, we have got very promising results in case of anti-inflammations. So these are the publication from the camel milk and goat milk or sheep milk on antioxidative activity. We have also checked the anti-diabetic, anti-hypertensive activity for the sheep milk, which is published in the Frontiers in Chemistry. The similar kind of things we have checked here, the different enzyme inhibitions from the sheep milk, that is the Panchali breed, and we also check the anti-inflammations of that Panchali sheep milk peptides. And you can see that this TNF alpha, if we LPS can increase their concentration, or the TNF alpha concentration is quite high, but when we are giving these sheep milk, fermented sheep milk peptides, you can see that significantly that is reduced as per the control. Similar for the IL-6, interleukin 6 and interleukin 1 beta for causing the inflammations in the cell. So these fermented sheep milk peptides has a good impact on different inflammations. We have also checked their SDS profile and 2D spots of those sheep milk, because that spots were purified, and then we have sequenced these sheep milk peptides. And we have also see the structure of those peptides in CLSM, confocal laser scanning microscope. So it is the unfermented one, or after fermentation, you can see the proteins are getting broken down in the smaller particles. And we also check the particle size distributions. So in the unfermented, it is quite intact, but after fermentations and when we pass through the different cut-off membranes, they are getting distributed. The antioxidant activity of different non-bovine milk, you can see these are the peptides which having the antioxidant activities. They are extracted from goat, camel, sheep, and donkey milk. Then anti-cancer activity. Cancer is a disease caused by the loss of self-control of the cell, because the apoptosis, the apoptosis is the programmed cell death. When it is getting disturbed, then the healthy cell or the normal cell converted to the cancerous cells. So about 7 million people die from cancer-related cases every year. And anti-cancer peptides have many properties such as high specificity, low side effects, and acceptable tumor penetrations. So they consider to have a great potential to prevent the cancer at different stages, such as initiation, promotion, and in progression also. But there is no comprehensive agreement on these ACPs. Okay, mechanism of action. So still their mechanism is not clear that how these peptides can inhibit these cancerous cells for proliferation and make them back to the healthy cells. So camel milk, when hydrolyzed by the pepsin, they have shown some kind of anti-cancer properties, because there is a study in 2017. These peptides have the anti-cancer activities. Anti-cancer peptides are divided into three categories based on their mechanism of cell entry. First is the pore-forming peptides, then cell-penetrating, and tumor-targeting. So different peptides follow different pathways to uh, inhibit the cancerous cells growth. So these are the bioactive peptides derived from the milk products of non-bovine species. Not only anti-cancers, they are S or anti-diabetic, antibacterial, okay, from different kinds of product. Still we are talking about the milk. Now you can see this is sheep milk feta cheese, sheep milk, this cheese made from sheep milk, then sheep milk roquefort cheese, sheep milk yogurt, goat milk kefir, and also another one is goat milk kefir. So these are the different products that contains different kinds of peptide sequences from different fragments, beta caseins or beta lactoglobin or kappa caseins, and they have a different biofunctional. ACE inhibitory means they are anti-hypertensive peptides, antibacterial, and DPP4 means anti-diabetics. So these are the different products made from the different non-bovine milks, which is familiar or popular in different parts of the world. It